All right, here we go. This is our question 2. And this is the one where we have to think a bit more about graphs. Okay, we're looking at the equation PV equal to NKT, describing the behavior of an ideal gas. We've got a fixed mass and constant temperature, where K is a constant. Okay, the student does this by making some measures of P and V, and we've got a table here. Now, you'll have noticed at the beginning that this was empty, and so even before I read the question, I filled in that gap. I probably shouldn't have done, but I did. Okay, why? Well, an empty table, to me, I'm a bit of a control freak and I'm a bit of a perfectionist. It needs to be full, okay? But we're almost definitely going to use that later. If there's a gap, it is there for a reason. Now, the way we do this is we want to calculate 1 over V in terms of 10 to the 4. So what I'm going to do is firstly take my V value, 1.54 times 10 to the minus 5. I'm going to do 1 over that V value, and I'm going to get 64935. That comes out as 6.49 times 10 to the 4, and so I'm going to put that 6.49 in there. Okay, notice all these values are to 3 significant figures. Yours should be as well. Even if you got 64935, change it to 3 significant figures. That will help you with the next part. Okay, now I've also done a little bit of a check here because I know the graph is coming. I've changed this value from 103 kPa to 10.3 times 10 to the 4 PA, and that's going to be important later. Okay, so if I just again move this one over, apologies. All right, firstly, I was asked there to plot that missing point, okay, on the graph, and I've done so there. All right, this is our missing point, and you'll notice we then are asked to draw a nice best fit line. Now that best fit line, it says in the mark scheme, should have an even spread. We want the same number of particles above and below. I've got a couple on the line, I've got 1 below, I've got 2 above. That looks pretty good to me. Okay, now we're being asked to if this relationship this graph can be used to prove the relationship PV equal to K. Well, we've got P on the y-axis and V on the and 1 over V on the x-axis. So if PV is equal to K, well, then that's saying we should have an inverse proportional relationships. We plotted 1 over V. The graph should have a constant gradient, positive gradient, and it should pass through the origin. Okay, now this is a 3-mark question. I noticed in the mark scheme, if you went down this route, you probably should say something like, well, we need to replot the graph to make sure that it fits, that it hits the origin. You could also obtain the equation, of this straight line to make sure that it hits through the origin. Okay. Another strategy you could talk about is just simply taking the pairs of plots, and they should multiply to make a PV equal K. We should do this multiple times. They should be within 10% of each other. If you found that PV equals, 5, then the other one should equal something like 5 as well. Maybe not exactly 5, because that's the world that we work in. Okay, a 3-mark question, that one. I think it's kind of quite a lot going on there. Okay, I wouldn't be surprised if you dropped a mark here purely just because there's quite a lot there to get through. Okay, we're then going to think about using this graph to determine K. Well, K is going to be the gradient of this graph. Okay, so all we have to do is take 2 points on the graph. Now, what I've done here is made it really clear which points I've taken. I put a dot there, take a circle around it, and I find the gradient there. Okay, I've found the points there. We've got 11.4, we've got an 8.9, etc., etc. Okay. Sorry, we've got 9.3. Oops, I made a mistake there. Should be a 9.2. That's why my result was a bit out. Okay, you're going to take your data and you're going to calculate. Okay, you calculate the gradient. You need to use 2 points from the line. Now I've just identified there. I think I've made a little bit of a mistake here. Okay, I've misread one of my graphs because I've been trying to do it too quickly. However, that might lose me one of my marks. Okay, you're going to notice here that you're going to cancel these 10 to the 4s. All right, and you're going to end up with a relatively small number, sort of surprisingly small number here. Okay, so we need to get the gradient of our graph there. I'm sure there's another way of doing it using the values themselves. However, to do that, I think you have to do it multiple times, and that's quite a lot of work. Okay. Last bits now, we're going to think about units. Okay, now K, we want to find its units. K is the ratio of P to 1 over V. It's the gradient of the graph, so therefore it's going to come from the ratio. So we can then think about units. Now P is pascals, and 1 over V, well, 1 over V is going to give meters to the minus cubed. 1 over that, okay, we're dividing, it's going to give you meters cubed on the top here. So we've got basically Pascal meters cubed. Now, if you know anything about pascals, if you times them by meters squared, you get newtons. So we've got Pascal meters squared, that's going to give me newtons times meters. That, you could leave it here as newtons, meters, but you can also call this joules. Okay, this is product of P and B, gives you something in joules. You also could express this in SI base units. Okay, it's absolutely fine here. You would then get joules, which all of you are telling me right now is kilogram meters squared per second squared. All right, last thing to do, we're kind of relating this to our course now. We're being told the temperature now, okay, and we're being asked to determine the number of molecules in the fixed gas. Now we know PV equal to NKT, okay. If we just separate this out, P is equal to NKT times 1 over V, which means that this capital K that we termed out in the first place, is equal to this NKT. It's a bit annoying here, we've got two Ks, a big one and a small one, okay. So my original capital K value is 1.5. We're going to take that and divide it by the Boltzmann constant and the temperature. 1.38 times 10 to the minus 23 times 291, which gives you a number, in my case, 3.73 times 10 to the 20. Now I've highlighted that in orange because that's not the same as in the mark scheme. It's absolutely fine. You can get a different answer. All right. If your answers are wrong, then I suppose there are chances that you've made a mistake, like I did here. I reckon I'd lose a mark here because I've misread my graph. However, it's also sometimes just because of rounding, etc. So do not expect when you're going through these mark schemes your answer to be exactly the same. The important thing, folks, is the process. It is not the value. Okay, you should be getting close, of course, but not exactly the same. I've noticed in various times, especially when we're rounding, it can really have an impact. So don't overthink it when you're looking at your answers.